this is really the fundamental thing to remember before you start working with mixed signal design, because it relates to something called the return path. And this is really what determines whether different types of signals will overlap and interfere with each other when you're routing around the PCB. And so this is one of the reasons that actually you'll see people implement really bad grounding practices in mixed signal PCBs. Either they don't really understand what the return path is, or maybe they get that there is a return path, but they're not quite sure how it's tracked. And so they implement some bad grounding practices to try and isolate signals in the board. So we're looking at this from a side view for now. But let's look at it from an overhead view just for the moment. Let's say I've got a component right here, and I've got a trace that I want to route to another component. And just for simplicity, I'll just put a 45-degree angle in here. And I've got another component over here. And I want to route this trace between these components. What happens is, here my signal starts traveling in this direction. And as my signal starts traveling, it induces a displacement current in the nearest ground plane. So let's just assume for a moment that there's a ground plane below this first layer. Well, what happens is the return path wants to induce directly below the trace. It's not exactly directly below the trace. What really happens is there's some current that's spread out a little bit below the trace. That spread out current, it follows roughly a Gaussian type distribution. Now, as the signal travels along this trace, it continuously induces this displacement current in the nearest ground plane. This is generally what happens with a digital signal. And when you have a digital signal, it's actually really easy. Modern digital signals running at, on the order of nanoseconds rise times. If we have nanoseconds rise times, this displacement current tends to get induced in the ground plane pretty close to this trace.